Okay, another 5.1 example. We have 3 to the negative first power, and this is another negative exponent rule. If you have 3 to the negative first, think of that number being over 1, having a denominator of 1 that you can't see. And that means that 3 to the negative first on top becomes 3 to the positive first on bottom. And so what we'd end up with is just 1 over 3 to the first is just 1 over 3, or 1/3. So it's kind of weird, 3 to the negative 1 first, negative 1 power, I should say. It's kind of like not the way you'd think of expressing the number 1/3, but they are the same. Okay. Another basic type problem. You have x to the 7th times x to the negative 2, and you could convert x to the negative 2 as 1 over x to the positive 2. Throw that down bottom. But sometimes it's easier to simplify first and then evaluate whether you have a negative power or a positive power. Because since you have like bases, x and x, and you're multiplying, you could say 7 plus a negative 2, which is 7 minus 2, and that's basically adding integers, and you'd end up with x to the 5th power. And so when you combine them together, it really does just end up being a positive power, and that's what the software wants. So you could just say submit. Okay, I think we had an example already like this, very similar. Order of operations says that 4 times, you deal with the exponent, the 4 squared, before you would multiply. So 4 squared is 4 times 4, which is 16, and then 16 times 3 is 48. Okay. This one is something to think about just briefly, where you have a power, and then what you have inside here is a negative number raised to that power. Remember that even powers, when you raise negative numbers to even powers, multiplying something by itself an even number of times when it's a negative will give you a positive result. If you raise a negative to an odd number of power, like a number 5, it's going to remain odd. Negative 10 times negative 10, negative 10, negative 10, negative 10, odd number of times. And if it's a power of 10, you can think about each power that you have, power of 5, corresponds to the number of zeros in your answer. Obviously, you could just punch it in to your calculator if you had one, but in my head, I see that it's negative because of the odd power and the negative base, and 5 zeros means negative 100,000. Okay, weird little example here, something we haven't looked at yet. 3x to the 0, take away y to the 0. What does it mean to have something to the 0 power? Well, if someone says, x to the 0, y to the 0, anything to the 0 power, except the weird case that you actually aren't going to see in here of 0 to the 0. That's indeterminate, but everything else, something to the 0 power is 1. So what this will become is 3 times 1. Take away 1. Okay, you're not going to raise 3 to the 0 power, but just x to the 0 becomes a 1. 3 times 1 is 3. And then because this will become a 1, and you'll be taking it away, it's 3 minus 1 equals 2. So just remember, raising something to the 0 power makes that piece a 1. And remember, in this case, you still have to take that 1 and multiply it with the 3. It doesn't affect the 3 with the 0 power. So final result is 2 for this problem. Okay, similar to one I did just a little bit ago. negative number raised to a power. Since that power is even, I'm expecting a positive result. And if you're talking about 6 raised to the 4th power, 6 times 6 times 6 times 6, I'm going to use the tools for that because I'm trying to think of what that calculation is. And without my pen and paper in front of me, it's going to be faster to just say 6. And notice I'm using the x to the y power button here. So 6 raised to the 4th power equals 1,296. I know it's a negative in here. I could have said negative 6 raised to the 4th power. But what I want to be careful of is that the negative is captured in the parentheses, so it is included when you're calculating the power. And I would have the same result then as raising positive 6 to the 4th. The result is going to be positive either way. Even power. Okay, x to the negative 7. That's the same as putting the x to the negative 7 down bottom as x to the positive 7. So 1 over x to the 7th. Okay, this little fraction, 15 and 3, those numbers reduce like you would typically expect. You get a 5, and then subtracting, you've got like bases here, but you've got a 6 power and a 2 power. Subtract the 2 from the 6, you're going to end up with x to the 4th. Make sure that's a power. The denominator is 1, so we don't have to create a fraction. We can just say 5 times x to the 4th. Okay, remember what x to the 0 is. X to the 0 is 1. So if I raise something to the 0 power, I get 1. I'm talking about x to the 6th over 1, which is just x to the 6th. It's like dividing it by 1. Okay.